Welcome back to ILR Performance. This is the next installment of the Tecate 4 teardown and reassembly series. We've got the bottom end all put together, including the ignition and the timing set. We're ready to assemble the cylinder with all the power valves and set the power valve timing. And then we're going to check the head. We're going to assemble the top end on the cases. And at the end of this video, it'll be ready to go on the dyno. At this point in time, what we have is a ILR Performance 330 big bore kit. It is a Tecate 4 cylinder that has been re-sleeved to take the larger bore with a cast iron liner, and it has dune porting in it, which is our dune / trail porting. It's an all-around porting. It has a lot more mid-range than the original porting. It's based more on a kind of fun all-around performance. Pulls really well from the bottom all the way to the top. I'm sure you'll see on the dyno runs it's got a really flat torque band, and it's got a nice performance pull all the way through the RPM. So right now we have the cylinder. The cylinder's all been prepped and repainted. It is honed to match the piston you'll see off to the right hand side. Right now we're going to go ahead and assemble power valves, and we'll talk about power valves a little bit. These are billet Tecate power valves. These happen to be the power valves that Joel Little is currently producing. They're top quality power valve. They're made out of, I believe, 6061 T651 aluminum. They're quite a bit stronger than stock. They are CNC machined, so they fit really well, and they should last probably the lifetime of the motor. This is the other power valve. You can see the machine work is very good. Good quality. All machining is within factory tolerance. It's a nice piece of work. This motor came with a really nice top end on it with factory Kawasaki power valves in it. However, Kawasaki power valves are prone to breakage, as anyone who's played with these Tecate 4s knows. And we want to make sure that this motor is pretty bulletproof when it goes out the door. So at no cost to the customer, when we do a 330, if it comes in with good factory power valves, we exchange those for the billet power valves at a no cost upgrade. If one of the power valves is broken, we just swap it out for the cost of the power valve. But we want to make sure when it goes out of the door here, it's got the best. In addition to the power valves, we have the actuator rod. We have all new O-rings. We have seals. We have all the gaskets. We have the top bushings, and we have the top bushing shims. Remember those top bushing shims because they're pretty critical when we get to the assembly. Since the bottom end is a stock stroke long rod bottom end, we're going to use one of our hyper-eutectic ILR Performance big bore pistons, and we're also going to use the ILR Performance base plate assembly. Between those two, that's going to get our deck height to where we want it, and the spacer plate is going to help us increase crankcase volume so we don't overpressurize the bottom end and end up blowing all the fuel out the exhaust pipe. So let's go ahead and assemble the power valves into the cylinder. We're going to check all the parts first, make sure everything's clean, fits good, and then we're going to check our tolerances and set our power valve timing. So as you can see, the power valves are different. It's very important that the power valves be assembled in the correct side of the cylinder. If they're assembled in the wrong side of the cylinder, they won't open and close properly, and the ports won't flow properly. This is the power valve that goes in the left-hand side of the cylinder, and when I mean the left hand, I mean the left hand when the cylinder is assembled on the cases. This is the one that has the big cutout in it. This is the power valve for the right hand side of the cylinder. You can see it has a slot through it. It doesn't have a full cutout. So we want to make sure that they go in the correct side of the cylinder. Since it's upside down, it looks like it's backwards. However, we flip the cylinder from front to rear, so right is right, left is left. So we're going to drop the power valve in and make sure the power valve turns freely and seats all the way down. We can hear it drop down and seat properly. We're going to do the same thing with the other side. Drop it down and make sure it spins freely. That's really important because most of these Tecate 4s have broken a power valve at one time or another, and the bores for the power valves get damaged. If there's any damage to these, they need to be reamed back out. You can do it yourself if you have a good 21 millimeter reamer, or you can take it to a machine shop and they can do that, but you want to make sure that they're good and clean. We ream all the bores for the power valves, and we ream the actuator shaft assembly whenever we do a big bore kit. It's just part of the machine work we do, so I know that those are in good shape. The next thing we're going to want to do is check for our clearance. These are the factory stainless steel shims that go between the power valve and the power valve lower bushing. It is absolutely critical that you put these back in the motor. If you run without these, you have an aluminum gear running on the top of an aluminum bushing, and all it'll do is make a big mess. The power valves won't actuate smoothly, and you'll have a lot of wear. These shims are 1/2 millimeter thick. So we're going to drop one on there. I'm going to drop one on there. The bushings currently do not have an O-ring on them, and that's intentional because we want to put them on and take them off. We're going to drop that one on, and we're going to drop that one on. Now, what you want to do is make sure that everything spins freely, and then the next thing you want to do is take a straight edge, and it can be, you know, something like this. This caliper has a really straight edge here. You can use a steel rule. There's a lot of things you can use, but you want to set it on here and hold it on the cylinder, and you want to make sure that when you pull up and down on the power valve, you can move it up and down at least 0.010 of an inch. So what we're doing is I'm pulling on this up and down to make sure that it moves. What I'm trying to check is to make sure that there's clearance when this is all assembled to allow the power valve to spin. I'm going to do the same thing over here. I'm going to pull up and down on this, and I know because I measured these when I first put them in earlier that there is about 12 thousandths clearance. So this is key because when we put this together, there's going to be a gasket between here and the spacer plate. That's going to be this gasket right here. And when we torque everything down, that gasket is going to bulge into this area just a tiny bit. And if it pushes down too hard on this bushing, it's going to pinch the power valve and not let the power valve actuate properly. It's going to make the power valve delay. It's going to hang things up, and it's going to cause a lot of unnecessarily wear and tear. This is really important to check if you buy the power valves from Joel Little. When Joel built his power valves, he was very careful, and he did a really, really good job. What that does is that helps us tighten up this tolerance. Now, if you happen to have a cylinder that has little or no wear in it, and the bushings have no wear in them, you might end up with a tight power valve. And what I mean by a tight power valve is that when you assemble all of this, the edge of this bushing may be higher than the gasket surface. You cannot run the motor like that. If you do that, the power valve will be jammed and you'll damage the motor. It's very easy to adjust. You simply take one side of this or both sides and you surface them down lightly with either a flat file or a belt sander, or if you happen to have a lathe, you can machine them down until you have the proper 10 to 20 thousandths. If you have greater than 20 thousandths movement up and down here, what you'll need to do is you'll need to get a stainless steel shim that's a little bit thicker than this one so that it takes up the tolerance. But the nice thing is, almost everything that I've ever assembled with Joel's power valves, I'll lightly face off both the bushings, take out off about 5 thousandths, and I'm almost always between that 10 and 20 thousandths. It's just something you need to check and make sure. We're going to check it again after we assemble the cylinder onto the bottom end, just to make sure everything's free when the gaskets are all torqued down, but that's where you want to be at this point in time. So the next thing we need to do is assemble in the actuator rod, and we're going to set the power valve timing. So in order to do that, we're going to go ahead and pull off our shim and our bushing. And since we've already checked these, we want to make sure that the shim and the bushing stay where they belong. And we're going to take the power valve actuator rod. Now, when you look at this power valve actuator rod, there's a line there and there's a line there. When you look at a power valve, the power valves, and I don't know how well you can see this, but the power valves have a notch between these two teeth, or actually the two teeth are machined down a small amount. It's done this way in a factory power valve. It's also done this way on Joel Little's power valves. There were some aftermarket power valves that were out there for a while that did not have this in there. If that's the case, then you're going to have to take a few more minutes to check the actual timing of the valves themselves to get it set. But as long as they have these two machined down gear teeth, you're good to go. So I'm going to drop those in there. This is going to go in. Big end's going to go in first. It doesn't really matter at this point. Ultimately, the teeth are going to end up pointing towards the gears. But for now, what we're going to do is we're going to get them in there and get the lines lined up. So in order to get these in there, you're going to slide this in. It's going to hit the power valve. So you're going to lift this power valve up gently until the actuator slides in. It's going to get up to the next power valve. You're going to lift it up a little bit, and then you're going to slide it in. Once you have it slid in, if you rotate it around, the gears will drop back down. Now, this is where the timing becomes important, and I'll see if I can zoom in to give you guys a better look. So this is where the power valve timing comes in. What we're going to do is we're going to move our power valve actuator rod until we can see that line. And now we can see the line down there and right down there, but we can see the notch in this power valve is over here. The notch is clear over here. So all we have to do is lift them up just a little bit, rotate them around until the two teeth, got her off one tooth there, till the two teeth straddle the line. We're going to do the same over here till the two teeth straddle the line. I have to give that one more go. There we go. Okay. So we can see right now, back in there, there's the line, and there's the two teeth straddling the line. There's the line down here, and the two teeth straddling the line. That means that the power valves are both timed. It doesn't matter if this is a little to the left or a little to the right. The key is that that mark should be between the two teeth that are machined down. Once you have that done, you can put your washer on. Put your washer on. Now we want to go ahead and put the O-rings onto the bushings. I'll go ahead and put the O-rings onto the bushings. We're going to push the bushing down in the bore. Do the same to the other side. Push the O-ring down into the bore. Moving everything all over. Okay. Now, what you'll find is the power valve actuator will move nice and smooth. You'll notice that I put everything together without any lubricant. I'm going to put a little bit of lubricant on it in a couple of minutes. However, If you over lubricate the power valves, all that happens when the motor gets warm is that the excess lubricant just turns into a gooey mess. It's important to have a little bit of lubricant. We're going to use some two-stroke oil, but that's all we're going to use on there, and we're going to go ahead and do that in just a second. So let me zoom back out. Now that we're zoomed back out, we're going to go ahead and assemble the last couple of parts. This is the bushing that goes on the end of the small end of the power valve. It has a seal in it, and it has an O-ring around the outside of it. Most of the time, if the power valve is drooling oil out of the little plastic power valve actuator cover on top of the clutch cover, it's because the seal on the inside of here has gone bad. It needs to be replaced periodically. It doesn't last forever. It's pretty simple. You pop it out and put a new one in. Like I said in the earlier video, if you buy a gasket set from us, it comes with every seal needed for the motor. That includes the seal that goes inside of here. That is this little seal right here, and it includes the O-ring here. So we're going to go ahead and put those in real quick, and we'll come back and we'll put that into the motor. All right, we have the seal installed into the bushing. The O-ring's on there now. You can see there's a little bit of shiny spots on the outside of this. That tells me that the O-ring was bad a long time ago, and it allowed this bushing to move in and out on its own. We're going to take care of that when we put it back together so it can't happen again. The other thing I noticed on this particular one is it was probably out of time, because you can see where the rack actually pushed on to the end of the bushing. But we're going to put a little bit of sealer on the outside of this, which is going to help us glue it into the bore and keep it from moving later on. A little bit of Loctite 515 on the outside of the bushing. Don't need a whole lot. We want to make sure we wipe it down a little bit. What we're trying to do is make sure that this glues in really well. Then we're going to put a little bit of grease on the inside of the bushing and the seal. Now the bushing goes into the cylinder right here with the seal on the outside. Simply slides over the shaft. And it pushes in place. Now, sometimes it's a little stubborn, so it's okay to tap on that lightly with a punch or a socket. I'm going to gently tap on that with a soft brass punch till it seats, and then we're going to hold it in with this screw. We're going to put a dab of Loctite on that screw and go ahead and just screw it in hand tight. That's a 4mm screw going into a piece of aluminum. You don't need to kill it. You don't need to use an impact. What it does is it retains this bushing. So the large head on the screw is simply going over the edge of the bushing, and it retains it. That's its only job. So now everything's in place, works nice and smooth. And we are good to move on to the next step. So the last part, as far as the power valves go, is the plug that goes on the end. Pretty simple, pretty straightforward. There is an aluminum washer. Use the factory washer. Don't go get a washer somewhere else or find something else. or reuse an old one that's all crushed and bent. This washer fits over here, and when it screws onto the end of the cylinder, it is the stop for the shaft. So the shaft travels up until it touches this. If you change the thickness on the washer, you change where that shaft stops at, and that's an important thing in the movement of the motor. So again, we're going to put a little bit of sealer on these threads, and then we're going to go ahead and assemble it. This takes a 6mm Allen. Put a little bit of sealer on there. We're simply going to screw it in and snug it down. Again, all of these parts are going into a cast iron cylinder, or cast aluminum cylinder, not cast iron. And we don't want to over torque them. They simply need to be snugged down good. The Loctite's going to keep everything in and keep it from leaking, so we don't have to worry about anything coming loose. So we are now done with the power valve. It actuates freely, everything works good. The last thing we're going to do is get a brand new washer for the water drain plug that goes in the side of the cylinder over here. We're going to go ahead and put that plug in. We'll put the base gasket and the base plate on, and we'll go ahead and assemble the top end. This is something I want to show you guys before I put the cylinder back onto the cases. We do this with all of our long rod motors, all of our stroker motors. We occasionally will do it on a stock rod, stock motor for a special occasion, but the ports on the outside edge of the cylinder of a Tecate or any of the 250 cylinders is actually larger than the case. And when you bolt the cylinder onto the case, there's a pretty pronounced step there. We custom make this spacer plate and all of our spacer plates that come in different thicknesses, and they match the engine case. So the holes on the inside of our spacer plate are actually the same size as the engine case. They're slightly smaller than the cylinder. When we build a motor, we calculate all the dimensions. We figure out what base gaskets we're going to need. We put a small dowel pin, metal roll pin right here, and a metal roll pin right back over here. You can see this one over here as well as this one. The gasket assembles onto those pins, and the plate, you can see, also has 2 pins, and the plate goes onto those roll pins and it taps on very lightly. We do this before we port the cylinder, so we know that the bottom of this matches the case. We check each one before it goes on, and if there's any minor trimming, we do that first. And then we port match from this edge all the way through the port. So all the porting is done with this plate on. So we know that when we bolt the cylinder on, we have a nice transition from the cases into the transfer port. Picks up a little bit more airflow. The biggest thing is it gets rid of that turbulence that normally happens in the sides of the transfer port on the Tecate 4-cylinder. The other nice thing that it happens to do is, in this case, it keeps all the power valves in, because right now this plate is attached through those roll pins and the 2 power valves are in there, and we are ready to install it onto the case. All right, we're back to the completed bottom end, and we're ready to install our piston and cylinder. First thing we're going to do is go ahead and use a little bit of 2-stroke lube and lubricate all the lower end parts lightly. Don't need to overdo this. Go ahead and put a little bit of oil on the wrist pin. Put the wrist pin into the rod and roll it around. Make sure everything is lubed. Go ahead and pull the pin out of the way. That's about as much lube as you need on the bottom end. So now we have our piston. This piston has a window mod in it. It has a tapered ring package on it, a stainless steel ring package with a chrome face, which is pretty reliable, lasts a long time. Don't know how well you can see, but I have installed the circlip on one side already. That's just going to make it easier when I go ahead and assemble everything. I have a little bit of lube on the wrist pin right now because I used it when I lubricated the cylinder. And now I'm going to go ahead and put the piston on the rod and push it in and put the circlip in. All right, we've got the bearing in here. We're simply going to slide the piston on. Go ahead and put the pin all the way in until it pushes up against the circlip on the far side. And we're going to install the last circlip. When you install that circlip, you want to look all the way around and make sure that circlip is all the way in its groove. Push on either side. The other thing you want to make sure of is the groove on the end of the opening in the end of the circlip either needs to point straight up or point straight down. It doesn't matter which, as long as the opening is not pointed towards the back or towards the front. If you put the opening towards the front or towards the back at high RPM, the circlip will come out of the piston. So you always want to make sure the opening is straight down or straight up. In this case, it's straight up. I've already gapped the rings, or actually I didn't have to gap them. I checked the rings in the bore. The gap was perfect. Both rings are installed. So now I'm ready to go ahead and put on the cylinder. I like to put a small amount of two-stroke oil on the rings, not much. Again, excess oil just turns into goo later on, so don't overdo it. This is just a little bit extra of protection for when I roll it through. Okay, the ring pin for the top ring is right here. Ring pin for the bottom ring is right here. I've got the rings lined up. So I'm gently going to compress them with my fingers. That's all I need. I don't need a ring compressor or anything fancy like that. And I'm simply going to slide the cylinder over the rings. Then I'm going to put it over the studs so I can line it up and gently wiggle it down onto the bottom end. If you have to push on it at all, other than just gently pushing down, if it wants to stop, go ahead and stop. Pull the cylinder back off. Make sure you don't have a ring hung up. If the ring hangs up, sometimes the ring will hang up on the intake port. That's really rare on a Kawasaki, but in some motors that does happen. But if anything doesn't feel like it's moving freely, go ahead and stop immediately. As soon as the cylinder's on, you can gently hold down on the cylinder, rotate it through, make sure that nothing's dragging or hanging up. And if everything went together good, you're ready to go ahead and torque this cylinder base on. I replace the cylinder base nuts and the cylinder head nuts every time we do a rebuild. I use these flange nuts, Japanese made, ISO standard flange nuts, but you can see on the bottom side of them it's serrated. That acts like a lock washer, but it's built into the flange. Drop that one. Built into the flange. That way the cylinder nuts go down and they lock. They can't back off. I do retorque them twice. Once after the first heat cycle and once after it's been run on the dyno for break-in, just to make sure they're good to go. But these nuts stay on there and they stay locked down, and I don't ever have a problem with them coming loose. So we'll go ahead and spin those down on, and we will snug those down. You want to make sure when you're tightening these down, you do a cross pattern so that you don't over torque anything down on one corner. All right, cylinder's tightened down on. Want to make sure this rolls nice and free. Then we're going to start doing some checks. I build almost all my motors to what's referred to as a zero deck height motor. What that means is that when we roll this motor up to top dead center, you can see the edge of the piston is exactly the same place as the edge of the top gasket surface. The reason I do that is because it gives me the most accurate timing in terms of porting. So all my porting specs are based on zero deck. So since the edge of the piston is what opens and closes the ports on a two-stroke, the edge of the piston being zero to the deck means my dimensions down from the deck are nuts on, and it allows me to control squish 100% with the head gasket. So when I cut the head with no step in it, generally, and then I control my squish clearance with the thickness of the head gasket. Occasionally, I'll build a custom motor that'll be slightly different, and I may be above or below, and in fact stroker motors tend to go above, but that's just the fact that the piston travels farther than the current cylinder is. But in this case, this is a stock stroke, long rod, zero deck motor. So you can see that even though it has an 8mm longer rod, we've used a piston that's shorter from the pin to the top of the piston, but not the full 8mm, and we've compensated for the difference between the two with the spacer plate. And we want the spacer plate in there so that we don't over pressurize the bottom end and lose cylinder efficiency. So that's the first thing we want to check, make sure all our calculations came out right. The next thing we're going to do is we're going to check the power valve to make sure that it moves freely. And I'm going to move you around here so that you can see what I'm checking. So this is the power valve actuator rod that we installed just a little bit ago. What you're going to see is I'm going to gently push and pull on this without much force at all. I can move those power valves in and out freely. That means that when I torqued everything down and the gasket squished into the bushing area, I didn't pinch the bushing down. Everything's lined up and it's nice and free. You'll notice, or anybody who's ever worked on a Tecate, whether it's a three-wheeler, four-wheeler, or even a KX, you'll recall that there's a sleeve that goes on here that locks into the power valve actuator rod. I deliberately did not put that on when I put the cylinder together because I wanted to be able to do this check, as well as we're going to loosen this nut up just before we put the rubber boot on. We're going to let this flex back, put that on, and we're going to set the tension of this, or we're going to set the location of this actuator rod so it's at the fully closed position. So remember when I was talking earlier about the thickness of the washer on the back side? That is what stops this from going in. If that washer was thinner, it would not go in as far. If that washer was thicker, it would allow the rod to go in too far. Right now, when I push this all the way in, I know that both the power valves are fully closed. So when I loosen this up, put the sleeve on here and the circlips, I'm going to reset this arm so that when the valves are fully closed, The arm has no tension on it, and I know that the actuator mechanism is in the fully closed position when the power valves are in the fully closed position. I get these in all the time where somebody has loosened this nut up and moved it. Like, for example, this may have been out here when they tighten this nut down, and what happens is when the power valve tries to pull all the way open, it runs out of travel here before the governor runs out of travel, and it bends the mechanism inside. The other thing is, if this is pulled out, when it's idling, you get poor low speed and poor idling quality, which is half the reason a lot of people can't get a motor to jet right on the bottom end, because the power valves are open. So we want this all the way in, and we're going to go ahead and take care of that in a few minutes. But before we do that, we're going to go ahead and put the head on, and we're going to check our squish clearance. As I talked about earlier in this video, we're zero deck height. We control our squish clearance with the head gasket thickness. So this is a 45 thousandths thick composite head gasket. It has, you can't really see it all that well, it has a stainless steel fire ring. Behind the fire ring is a copper ring, and this is a composite gasket. It has fiber on both sides. It has a wire mesh inside of it, and it's currently been coated with 2 coats of copper coat spray adhesive. I'm going to go ahead and gently push this down on without making too big of a mess, making sure everything fits. This gasket will go up to a 78 millimeter bore. I take that back. This is up to a 77 millimeter bore. Our 330 big bore kits start at 76 millimeter bore. We have 76 and a half, 77, 77 and a half, and 78. So this particular head gasket will take up to the 76 and a half and the 77. We do offer a bigger gasket if you go bigger than that, but this gives us the right amount of thickness for the gasket and the clearance for the piston. So now we're going to go ahead and assemble the head and torque it down to spec. This is the head that's been remachined to take the 330 big bore. It's a factory Kawasaki head. We glass bead it, we machine it to the correct CCs for the compression ratio that we want. You can see it drops right on, and we're going to go ahead and put some head bolts on. All the torque specs for this motor from Kawasaki are what are considered dry torque specs. That means there's no lubricant on any of the fasteners when you torque them on. Once again, we're going to replace all the head nuts. We're using a locking nut. We're going to go ahead and replace all 7 of these with brand new nuts. And we're going to torque them down to the factory spec. We're going to go ahead and install the front 3 bolts as well. But in addition to the factory bolt, which we're going to replace all 3 of them, we're going to put a 1 millimeter thick flat washer on there. That is not the way they come from the factory. However, one of the issues with this motor has always been keeping the front tight without the bolts wanting to dig into the head excessively. So the washer spreads the load out, gives us a better torque spec, and it keeps the bolts from wanting to wear into the head. It's important to put these 3 bolts in just finger tight right now. We're going to torque them after we torque the head, or after we torque the 7 main head bolts. But we want to make sure they're in now so that they screw in properly. There's no binding or problems with that. Plus we want to make sure that they all go in. There are no dowel pins between the head and the cylinder on a Tecate. The bore of the 7 head bolts as well as the shoulder on the stud is all that really aligns them. We do make sure when we machine the head that each head is custom machined to match the cylinder so that the bore is concentric with the squish band that we cut in the head. However, we want to make sure that everything's in at least finger tight before we start torquing anything down. Factory torque spec on these head bolts is 18 to 22 foot-pounds. So we're going to torque these to 20 foot-pounds, which is right in the middle, but we're going to do it in 2 steps. And we're going to do it in the conventional star pattern. We're going to start out at 15 pounds. And we're going to go around in a star pattern so we get everything up to 15. And we're going to go around, double check that. Now we're going to step it up to 20 foot-pounds. And we're just going to double check it. All right. We will retorque all of those head bolts later on, as well as do an actual torque on the cylinder base bolts. But we're going to wait until it's on the dynamometer and we've done a heat cycle on the motor just to make sure that everything has the chance to warm up, seal properly. We'll talk about that a little bit more when it's on the dyno. So now we're going to tighten down the front 3 bolts. They're just going to be hand tight. You do not need to kill these 3 bolts. They're simply there to keep the gasket surface sealed properly in the exhaust chamber when the power valves are closed. They're 6mm bolts. Don't kill them, don't strip them. It's just going to make your life more difficult. That is all there is to it. Okay. Next thing we want to do is check the squish clearance and make sure we're where we want to be. The next thing we want to do is check our squish clearance. It doesn't matter if this is a big bore motor, a stock bore motor, 310, 330, 350. This is something you should always do when you put a motor back together. Depends on where you buy your gaskets from, where you buy your pistons from, how much has been done on the cylinder over time. But the squish clearance is the clearance between the top of the piston and the bottom of the head on the outside edge where the quench area is. If the quench area is too tight, then at higher RPM the piston will hit the head. That's not a good thing. If the quench area or the squish clearance is too large, then it won't properly quench, it won't cool the outside of the piston, and you'll have overheating of the outside of the piston and you'll lose a bunch of horsepower. Maybe not peak horsepower, but you'll lose a bunch of available torque. So the way that we're going to do that is we're going to use a piece of 1/8 inch. This is acid core solder. And the reason I use acid core solder is because it's hollow, because there's flux in it. However, you want to make sure you use 1/8 inch to start with, because we want our squish clearance between 45 and 60 thousandths of an inch, and we want about a 1 degree angle, between 1 and a 2 degree angle greater on the head than the piston. And I'll show you what that means when we go ahead and do that. So you can see I've bent this piece of solder This is a 76 millimeter bore, so I've bent this so that the distance from here to here is about 40 millimeters, which is a little more than half of the bore. That way I can get in there and touch the cylinder wall and make sure I have an accurate reading. What I'm going to do is I'm going to turn the flywheel, I'm going to run the piston down to the bottom, I'm going to drop this in, and when I say drop it in, I don't mean drop it inside the motor. I'm going to put this down the spark plug hole with the solder pointed towards the side. Do not point it towards the front, the back, or the front, because you'll get an incorrect reading. It needs to go towards the side, doesn't matter which side. So you're going to slip it in there, and when you get it in there, you're going to feel it touch the cylinder wall. And then what you're going to do is you're going to rotate the flywheel clockwise, and you're going to need to do this with a ratchet. You're rotating it clockwise to keep the bolt tight, but you're simply going to rotate the flywheel through a couple of times until you have squished the solder. And you can see, hopefully you can see that the solder has been squished. You have the thickness on the solder. Now, the solder should be slightly thicker here than it is back here, and that's because we want the angle on the head to be a little bit steeper than the angle of the piston, so that when it comes to top dead center, it squishes the fuel in towards the spark plug and not away from the spark plug. So what we're going to do now is we're going to go ahead and measure that thickness and find out if we're between our 45 and 60 thousandths that we want. Okay, I don't know how well you can see what's on the indicator, but right now I'm measuring the squish portion and I'm looking at 57 thousandths of an inch. So we wanted between 45 and 60, so we're still under 60, but we're a little bit on the big side. We're going to go ahead and run this on the dyno the way it is. This is well within the ideal range. However, I may pop the head off and take a couple thousandths off the head after we run it on the dyno, depending on what we get for reading. So 56 and a half, 57 thousandths, we're right in where we want to be. Just for reference, if we slide back up to the thicker portion, you can see we've gone up to about 72 thousandths. That tells us that we're thicker here than we are here. That's critical because we want to make sure that we are squishing the fuel from the outside edge of the piston up towards the spark plug at top dead center. So we are where we want to be. All of our calculations came out right. We are going to heat cycle the motor on the dyno, make sure we get it up to temp. We're going to retorque everything. We're probably going to tighten that squish up by about 5 or 6 thousandths when we do that, and that's going to put us right in the sweet spot. If it doesn't tighten up enough, we'll probably take a few thousandths off the head, but we are where we want to be. So the next thing we're going to do is go ahead and put it on the dyno plate, and get the coupler on, get it mounted onto the dynamometer. So the next time you see this motor, it'll be bolted onto the dynamometer. It'll be ready for ignition. And when I say that, I mean the CDI box and the coil that we're going to run. We're going to go ahead and install the intake manifold that we're going to run with the reed and the carb. And we're going to pick a pipe. We're going to pick a dyno pipe and do a couple runs. So this concludes getting the top end on. I don't think you're going to see it again until it's on the dyno and just about ready to run. We'll talk about what our final setup is, and then we'll do some dyno runs and see what kind of power this motor makes. Once again, thanks for watching. Appreciate your support. Please subscribe and like the videos. Subscriptions are what help us continue to make more videos. And I want to finish this series out. I think you'll enjoy seeing what kind of horsepower this 330 makes. Talk to you later. Bye.